If you've ever worked in an industrial plant, you will most likely have seen this type of motor. It is incredibly popular. This induction motor we're looking at now is what they call a squirrel cage induction motor. I'll explain to you what that is in a moment, but for now it's important just to realise that there is another type of induction motor, it's just not as popular as this one. Let's add the rotor again. You can also add the bearings, and now you can already see that we're starting to construct our motor. We know we've got the stator windings, we've got the stator core. Let's now add our frame, and now you can see we're really starting to get our entire motor. And the best part about this, if we just reset everything, is that we now know exactly what each of these components are doing and why. So here is our rotor. The one on the bottom here is the one that we looked at earlier. But if we go upwards, you can see we've got this quite unique construction here. Again, here is one end clamp, here is another, and then we've got these bars that connect the two end clamps together, and they actually short out or create a short circuit between the two end clamps. This is our squirrel cage. Well, the rotor is made up of a series of very thin laminate steel plates. You can see them here. They're actually called laminations. That's what all these little lines are. And you can also see that there are some thicker lines, these ones here, cutting across the laminations. At either end of this stack of laminations are these two end clamps, one here and one here, and they press together in order to clamp all of our steel laminations together and stop them from moving. You can see that the stator surrounds the rotor. There's not much of a gap between the rotor itself and the stator. If we press play, you can see that the rotor is almost touching the stator windings, but not quite. The gap between the rotor and the stator is known as the air gap. What actually happens is we pass electrical current through the windings. You can see up here that we've got our connections to the terminal block. And as current flows through the windings, we create a magnetic field. And the magnetic field also induces current in our rotor. And the resultant force is what causes the rotor to rotate.